Hello, welcome back. And after our last video, where we discussed at a very high level what is the things that a data engineer needs to be prepared for if he or she is appearing for a FAANG level interview. Okay, so this video is a successor to that. We should be discussing, we from this video onwards, we'll start picking up every single points that we discussed on a high level and deep dive into that, break into list of problems that we need to practice and what things to do, things not to do. So just to recap, so this is all we discussed in the last video. So DSA, you should be prioritizing easy to medium level questions. Hard is not required. Okay, you will not encounter very hard problems. And in fact, um, lead code medium has few like 30 to 40 questions of lead code medium feels like hard. Okay, I don't know where you agree with me or not with this, but if you're practicing medium and you're able to solve medium not easily but very smoothly, like it is not bothering you, it is not troubling you, then you're good. You don't need to do hard questions for FAANG interviews. Okay, and one more thing that I need to I am repeating again, you should practice all DSA sessions questions only in Python. Okay, if you know Java, C++, very good. Keep that as a secondary language for now. But if you are into data engineering, if you know Python, it will definitely favor you because a lot of companies use Python, PySpark. Okay, so if they have a if they have a something in-house, they have built something in-house and there are legacy code that is running there, so they're not going to change something if you are a Java learner, right? So most of the company, I'm not saying Java is not being used. You'll find job listings where Java is also preferred, but it is like a 30-70. Okay, if it is, I mean, not even 30-70, 20-80 also. Okay, this is the ratio. 80% of the cases you'll find it in Python, and 20 to 25% of the cases you'll find it in Java or any other language, mostly in Java. Okay, so you decide which one do you want to target. So do you want to target this or this? If you know Java, okay, it's well enough to know both of them. Okay, so after you are done with DSA, so this is something that you need to do daily. Okay, at least do practice 1 to 2 questions. From I'll be discussing on what to practice, what not to practice. Cool. It's this. This is the DSA. You need to do it daily. Okay, cool. Coming back, the next round you can see it as a data modeling round when. This also will have like a mock session or a mock interviews where we'll discuss data modeling. You will take at least 5 to 6 real world data modeling interview questions. Okay, so after we're done with data modeling, we'll look into SQL, then we'll have Spark. So Spark involves both Spark concepts, that is for distributed processing, and then we should also practice actual coding in Spark. Okay, SQL, that's well and good, but they also expect you to write code in terms of data frame, like join with data frame. Do every single thing that you do using SQL, you should be also able to do it in Spark. Okay, so Spark also we will learn both of them, concept as well as coding. Then we'll also look into optimization with respect to both Spark and SQL. Spark will look into optimization with respect to, mostly like tuning, Spark tuning. There are a lot of advanced features that is there. Even though Spark handles everything on its own, like it is completely automated. Uh, like there is something called as AQE. Okay, and if you enable that, actually, enable most of the tuning. But apart from that, also you could also tune like how many nodes you want to set up, memory, operating OS memory, all these things you should be able to learn and tweak in order to improve something. A lot of times they'll ask you like if something is running slow, or like it's taking too much time, how do you optimize, what all things that you check. Okay, so these things also will be covering in the optimization step in this series. Then we'll pick up at least 4 to 5 projects that you need to do. So 4 to 5 for the 4 to 5 projects, I'll be giving you the complete setup. Like you need to like I'll tell you, what is I'll tell you the entire setup, like what is the requirement and what all things is expected and the final outcome. And you need to come up with that project. And we will also have a solution video for those projects as well. Cool. And coming to tools, yeah, we have a lot of tools, in the market for various reasons. Like they do serve a lot of other different functionalities. So mainly productionizing your code. So you will see companies using Databricks, Snowflake mainly these days. Okay, and on top of that, they will be having, of course, a cloud provider where everything like Snowflake and AWS in the backend, they always point to some cloud services provider. It can be AWS, Azure, but as like Python, like I did a comparison of Python and Java. So AWS and Azure is in the same similar fraction. Okay, so if the majority of the companies do use AWS these days. Okay, so you also can learn, like we'll also be teaching, like discussing DBT. Then we'll this is also a mandatory thing. You should be aware of Airflow. It's like orchestration tool. It's like a free source orchestration tool that you can use to monitor your pipelines. Okay, so you cannot deploy something without Airflow into production. So you should be able to monitor, you should be able to treat the logs, like get alerts. Okay, so yeah. And one more thing that I already told in the first video, you should be aware of Git. And as part of this series, we'll discuss a few, advanced cons, like not advanced, but few, in practice or a real world uh, Git. Okay, what a working professional in the industry, how do they use Git in their regular day-to-day job. We'll have some scenarios created and we'll demonstrate about Git. Yeah. So in this particular video, let's look completely into DSA. Okay, let's look into all the types of questions, all the topics, or the patterns that you should be looking into when you're in the DSA round. Okay, so very first round, round one could always be a DSA round. Okay, so it could be a coding round 70 to 80% of the time, or it could be a coding plus SQL coding round. Okay, both of them could be there. Okay, and it could also be a automated, like you have platforms like hacker rank. So companies will like ask HackerRank to conduct the DS around for them. Okay, this could also happen. This you have seen in your campus placement as well, but this could also very likely to happen. Anything out of these three options is very likely. So we are not going to miss DSA. It's very important for FAANG companies. So we will start with arrays. Okay, let's start with arrays. And in arrays, we have, as I said, you have to look for patterns. So in that particular patterns, you should be able to look into two pointers pattern. So given an array, 1, 2, 4, 5, you should have two pointers pointing to some location. And based on the condition, like based on what you're trying to solve, you should move these pointers so that you can actually compare something without actually not traversing the array in a nested format. You should avoid that. So two pointers approach can easily bring your order of n square approach to order of n. Okay. So yeah. So these are few problems that are listed. So this is like a 10 set of 10 questions for 2 pointers. So this is like a like very curated list of questions, and if once you have done the 10 questions in 2 pointers, you should be very confident on like similar questions from 2 pointers, where you should be able to see the pattern. You should be able to see, similar questions that has this exact same pattern. So yeah, that is the idea. Then we have sliding window. Again, like sliding window, given an array, you decide a window. Okay, you decide a window based on the start point and the end point of the window, and you do some operations inside that window. Like you don't care about what's happening outside. You're only looking into that particular window. Okay, so based on the condition, you keep moving that window. So let's say t equals at t equals 0, window is at here. So at t equals 1, the window might have moved a bit. Okay, and even the window size is not always the same. So it could be like in a given iteration, you could also try to, you know, expand the window a bit more. Yeah, expand it. So yeah, the base condition for this, of course, L, the left side, while you are doing a window movement, you should not do L minus, like you should not be beating R. Okay, that is the first condition, and R should not be beating the length. Okay, this is the same condition here as well. So if you're looking into 2 pointers and you're doing some operation, okay, you should always take care that L should not beat R. Okay, and R of course should not go beyond the length of the array. Okay, so yeah, so this is again like list of questions that you should do. And one thing that I forgot to mention here, I have simplified few things for you. So this question, you these are all lead code questions. So how are you supposed to solve these questions? Go to lead code. Okay. So once you're at lead code, go to problem section and simply search for this particular number. Okay, you could also paste this the text as well, like two sum, three sum. You will see a string match and it will show you all relevant problems. But if you want to get the exact same problem in a very short search, just search for 167 and it should pop you up this question. Okay, similarly 15 will pop you this question. So that is what is the idea. Every question here is properly curated from lead code, and the number is for you to easily identify the questions on lead code. Okay, I'll share you this, the entire PDF. Okay, no problem. You could always keep track of this. Good. Next up is prefix sum. So prefix sum is like we are given an array. Okay, 1 2 4 6 7. We're trying to store the prefix. First of all, we're trying to create an array and we try to store the prefix in the way, like if we are standing at 0th index, what is, if somebody asks me like what is the prefix sum for this? Prefix sum means everything that is here or before, it should be sum of all that. So very easy way to calculate is just iterate from left to right and keep summing, the left side plus the current side. Okay, so 1 plus 2, 1 plus 2 is 3, and 3 plus 4 is 7. Okay, 7 plus 6 is 13, 13 plus 7 is 20, and this goes on like this. So it's very easy, like the last sum plus the current value will give you the prefix sum. So once you have actually got this, you don't need to actually have a double loop and keep track of sum. So you prepare this prefix sum and it should give you a very good depth of solving these questions. Okay, so these 6 questions you should be able to solve, and wherever you are stuck, there is a section in lead code discussion. So go to the discussion, solve, see the solution. If that is not helping, go to YouTube and search for this. There are couple of like plenty of videos. So not digging deep into all the solutions that I'm presenting, because these things are readily available. Okay, so this series is mainly will focus mainly on the data engineering part of things. This part is already available. You could always look into this. Okay, and hash map, of course, like hash map, there is like it's like a dictionary. You When we say hash map or dictionary, let's understand we are referring to the same thing. So whenever you have a string and you just want to have a frequency map of the string, let's say C appears 4 times, like A appears 5 times. So any sort of key value pairs or any sort of counting, any sort of mapping. Okay, so con let's say how do you say, like let's say let's map India to its capital. So you can map India to New Delhi. Okay. So let's say there is a problem where you are given like, you know, these are uh, uh, these are the countries, and you should be doing something with the capital. So instead of doing a lot of if India, then New Delhi, if Sri Lanka, then Colombo. So to avoid those things, we just prepare this and use it. So if it is India, take the value of India. That's it. Or you don't need a condition if like so if you're looking for India, so and what the value passed to is like country passed to you is India. So simply do D of country. This should give you what's mapped to the value of India, which is New Delhi. Good. So you should be able to do all the question using hash map as a base, like base, problem uh, data structure. Okay. So you should be able to do this question. This should be enough. Okay, for you to get the gist of how dictionary could be used. Okay. Now moving on, let's look into binary search. So let's see 1, 2, 3, 4, 5, 6. If you are given a sorted array, okay, and you want to search for an element, let's say 6. Okay. So if it is a linear search, you start searching every element one by one. I know you guys know these things, right? So if it is a binary search, and what do we mean by binary search? Binary means 0 1, right? So you either take, like you either consider the like what the idea is always to split the equation into two halves. Okay. So meaning, if you are looking for 6, just go to the middle. Okay, just go to the middle and compare that with the element that you're trying to compare. So 6 is of course greater than the middle element. That means it cannot be in the left side, right? It should be present in the right side. Correct. So in the next scan, you better not scan the left side. So this part you can simply eliminate. Okay, you focus only on this part. So from a problem which was of order n in the first iteration, okay, or maybe a time complexity of n, then you reduce that to half. Okay, the next iteration, then you reduce that to n by 4. You keep like splitting the array into two halves and just doing analysis on one half. So it goes on like this, and this reduces to order of log n. Okay, so there is a huge difference in order of n, which is the linear time complexity, and order of log n. Okay, that is where binary search comes into picture. Okay, only if you are given a sorted array, these are the questions that you could practice. The Again, like go to lit code and find the numbers. Similarly for stack, you know what is a stack is. I'll not discuss that. uh, you have to learn to create every single data structure like stack, queue, um, everything should be curated from a list itself. Okay, so list itself should have a, like you should be able to understand, stack like well, last in first out. So something has come at the first, it will picked up at very last. So if you want to delete something from the very last of a list, you simply do list.pop. Okay, and if you want to, like, 5 is deleted and let's say you want to add a few items, just do list.append. Okay, so 5 is deleted, 6 is added, so do list append dot 6 and 6 is added. If you see it, in a vertical way, it looks like a stack if you see it this way. Got it? So yeah, these are the questions you could practice for stack. Okay, now coming to DP. Okay, there are a lot of rumors like, DP is not required, it is too hard for to prepare for, and nobody asks for DP questions to a data engineer. These are all false. Okay, I myself have been asked the DP level questions in my interviews, and I have had friends who had interviewed for Uber, Amazon, okay, and Google. So we are preparing for these companies, right? So these companies do ask for DP. Okay, although like you cannot expect, even in DP also there is a level of questions. So in DP also we have hard problems, and DP we have medium problems as well. Okay, medium problems as in they're not very hard to formulate. They have a very common patterns across. So these are mostly medium questions. Mostly you could see them being tagged as hard, in few of the lead code questions, but once you understand them, like, it will all looks very similar to you and you should be able to handle. These are the very few questions that you should do. Okay, like coin change, I have seen this couple of times in my interview. Maximum observer array, house robber, climbing stairs, equal partition subset. Okay, so yeah, don't ignore TP. Okay, don't. If you want, you can, and don't keep DP towards very end. Okay, I have seen, like, many people do it and they finally say, okay, we are done at DP is left anyways, nobody asked DP, so let's just ignore it. So this is not the right approach. Do it somewhere in the middle, just like I have mentioned. Follow this order. Okay, this is follow this order. This is, you should be, like, doing it in this particular order. Okay, cool. Next comes up as greedy. So greedy is something like, you are greedy and you pick up something that is the highest. Let's say a apple, or let's say a fruit that is the highest price or the lowest price. Okay, so let's say you just want your bag to be full and you just want fruits. So there are a lot of fruits in the market, and you just want a bag full of fruits. Okay, remember when we go to some relative's house, right? So we just want something to carry, and it should look full. Okay, so you pick up from the very lowest ranges of fruits. Okay, like, some fruit having a cost of 20 rupees per kg, pick them first, fill up your bag. Then, for variety, look for 30 rupees per kg and then 40 rupees per kg. So this way, your cost, to fill up the bag is like, at a very least cost, you are able to fill up the bag. And at the end of the day, that this is what you're looking at. So the questions could be like minimum cost to fill up a bag. Okay. So this could be your approach. Okay, where the problem is asking you to be greedy. Okay, so yeah, look into these set of questions. Okay, now coming to a very important topic, which is linked list. So I know in school colleges we have seen, schools teaching us in this particular format. Okay, like a pointer, and it points to the next node, and that's why we have been, like, visualizing linked list as a, very different thing than a list. Okay, which is not at all the case. Okay, so this is not how we should treat a linked list as. Okay, it's simply a user defined variable. Okay, you have defined a class. Okay, I know like in the school also they have defined us here. So you need not worry about the class and the next variable and the value. Okay, so this is there. Nobody's asking you to write a class definition for a list node. Okay, assume this is already there. Okay, assume list node is a data type. Okay, that makes everything very simple. So you just have this in your mind whenever you see a linked list. So this is like a pointed array, like pointed list. Every single node has a next, what is coming up next, and do some questions on this. Like like you can't expect questions like traversing a list. Okay, these are very basic. So you should know how do we reverse a linked list in place. Okay, how do you find the middle of a node? How do you delete a node? How do you find a circle? I mean, find a loop. So to give you example, so let's say 1, 2, 3, 4, 5, 6, 7. Okay, there is a loop here. Okay, and you are given to find a loop. Okay, to find the starting what is the starting position of the loop. So in this case you should be finding 3. Okay, these are very like conceptual questions. It will brush up your problem solving skills a lot, trust me. So these are the like top questions that you should do. Okay, I don't know it is 10 or 11, but yeah, approximately 10 set of questions. These are the questions that you should do. Okay, practice them. It will give you a very good clarity on linked list. Next up is a tree. So tree, let's focus on binary trees for now. If you have time, you could also look into binary search trees. Okay, binary search trees like order tree, like left one is always smaller, right one is always larger. So do practice some like at least 2 to 3 questions on binary search trees as well. And for trees, I've already listed you the questions again. Okay, so do check out, level out like what is the order traversals, how what are the different types of traversals we can do on a tree. Okay, these are very important again. Okay, so this also gives you clarity of looking at a data structure, something to find some relation, right? To find a network of, so let's say somebody has a Netflix account, okay, and you want to find out like all the users that has Netflix account, and you draw a family tree. Okay, you want to find the youngest user having the Netflix account, or you want to see at a very like what are the leaf nodes. Okay, the very nodes where we don't have any other shares. Okay, they are not sharing anything, and they are the end consumer. It's just a random example, but you should be able to see a very big picture. You should be able to see problems in a different perspective once you practice tree. That is my entire like whatever this is what I'm trying to communicate from this. Okay, so once you're done with tree, there is something called as DFS. So don't get scared with DFS as well. So let's say DFS simply means, so if you are here, okay, 1, 2, 3. It's if you are trying to solve a 1D array questions, and you are trying to find out, at every like at a position 2. Okay, if I go forward, okay, if I consider this and go forward, what the problem reduces to is you should be passing the, you know up till here you have processed already, so you just do I+1. Okay, wherever you are there, just you need to process everything that is from the right hand side, and you could also go left hand side as well. Okay, if you want to go left hand side, you can always do I-1. So this is just example. So if you want to process everything in the left ones and everything in the right ones, okay, at every given node, then you could do this. Cool. So these are like number of islands is like my most favorite questions. Okay. So similar things like on lead code, you can find these questions and do practice these questions. This is just 6 questions, guys. So you should be able to do it. I mean, the entire purpose of this video is to keep you, in a mood to solve DSA. Okay, that's why the list is very curated. We are not going to solve hundreds of repetitive questions. We are going to pick up the baseline. We are going to understand the core root of the problem, and we are going to recognize the similar patterns and similar problems. That is the whole idea here. Okay, so that's about it for this particular video. And in the next session, in the next video, I'll be looking into data modeling. Okay, I will be sharing this particular list as a spreadsheet, or I'll just simply share this entire slide or PDF, whatever, in the description. Yeah, see you in the next one for data modeling.